Hello, my name is Professor Johnson, and today I will demonstrate the normal distribution, and we'll do some examples on our calculator. So here, suppose x is distributed normally 24, 8. The 24 represents the mu, and the 8 represents your sigma. Now, mu really is your mean, and sigma is really your standard deviation. So what I'm going to do is draw a little sketch here. Draw a little bell curve. This is my normal curve. Now we know the normal curve is symmetric about the mean. So I will represent 24 here about the mean. And then if you were interested, what you could do is you could do some other markings if you'd like. I like to mark 3 to the right and I like to mark 3 to the left. But what you do is you add a standard deviation away. So 24 plus 8 gives you 32. And then if you add 8 again, you have 40. And then if you add 8 again, right, you would be at 48. So what I'm doing is just showing how the values are distributed about. So now I could go to the left. I would just take 24, subtract 8, give you 16. I could subtract 8 again, that would give you 8. And if I subtract 8 again, it would give you 0. So you can do your standard deviation. Some teachers like to call these hops, right? You're hopping by standard deviations. That's just an informal way of saying it. Okay, so now let's look at some probabilities. To find probabilities, we need to use technology in the calculator, or you could use a z-score table. And if you wanted to use a z-score table, then you'd have to find the z-score of x equals 30 first, and then you would need the actual table. So I have the calculator. It'll be actually simpler to use the calculator. So what I'm going to do here is draw a little sketch again, and I'm going to mark where the mean is, 24, and then I know that with probability, I'm trying to find area under the curve. Now right now the area under the entire curve is 1, but I only am interested from 30 and then less than, so I'm shading to the left. So I'm interested in that shading region. So what I can do now is hit second vars, brings you to your distribution menu, and I'm going to pick normal CDF. Now here in the 84, it gives you lower, upper, mu, sigma. So when you hit normal CDF, it will ask you for the lower bound, the upper bound, the mu, and the standard deviation. You must put it in this order. Okay, so you must put it in this order. I will say normal CDF. The lower bound, we'll look at our shading. We're going all the way to the left forever and ever, so I can say -1e99. This is represented as scientific notation, and really it's just like putting -1 times 10 to the 99th power. It's just a really huge number to the left. You could think of it as negative infinity. You're going as far left as you possibly can imagine, and this curve gets closer and closer and closer to the x-axis as you go to the left. So by using -1e99, you've gone to the left as far as you possibly can. Now here, the upper bound, you get blocked by 30. So you go up to the right, and then you hit 30. And then mu, well, 24, and standard deviation was 8. So I will change all that in my calculator. So 30, 24, 8. I will paste that. I will hit enter. And then we have our probability, 0.773. Yeah, let's just take 0.773. So I will say this equals 0.773. 0.773 would be the probability. Let me show you how to do this with the 83. It would be very similar. So this would be if you didn't have MathPrint. You hit second vars. You still pick normal CDF. CDF because we're finding area under the curve. Now, unfortunately, it doesn't remind you of what you need to input. So you need to remember lower, upper, mu, sigma. Lower, upper, mu, sigma. So I need to first hit the little negative, and I'll say -1, and then I will hit second comma, will bring up that E, that brings you to the scientific notation, and then 99. So -1 E 99, that tells you to go as close to negative infinity, right? And then you hit comma, I will hit the upper bound, 30, you hit comma again, 24, comma, 8, close up your parentheses, and then you hit enter. And you can see here we get the same answer, just it's an extra step of remembering what you need to type in on your own. Okay. So there we go, we have our probability. And what I wanted to do is actually ask a similar question over here. Find the probability that x is greater than 30 now. So I'm going to draw this little sketch here. I'm going to mark 24, right? It's symmetric about the mean. If I can draw a nice one, there we go, that's a little bit better. I'll mark 30 again, but now I'm shading to the right. So you see the comparison with this first one here. I'll label that with yellow. So that shaded part was in yellow that we found before, right? We found that part to be 0.773. And then now, let me mark in green, I'm looking at 30 and then to the right, that shaded part to the right. Well, I know that the area under the curve must be 1. If you wanted to, you could hit 1 minus, and then you could hit second, then the little minus will bring up the answer that you previously had. And then you could see here that 22.227 would really be representative of the area to the right. So 22, let me zoom out a bit, 227. 0.227 would be this probability to the right. Okay, because the area under the curve must add up to 1. If you added up both those values, it would add up to 1. Now, the other way you could do this is hitting second vars, going to normal CDF, and then now the lower bound is actually 30. So 30 is the lower bound. Then I'll hit comma, and now I want to go all the way to the right as far as I possibly can imagine. Well, that right direction is the positive direction, so I could do +1 E99, and that's really, thinking about our scientific notation again, is just going towards positive infinity. So I put that, then comma, and then I can place 24, comma, 8 for mu and sigma, and when you hit enter, well, look at that, you do get the identical answer that you looked at before. So if you have the 84, it's a little bit nicer because you can hit second vars, go to number 2. It helps you keep organized. The lower bound now was 30, the upper bound was 1, and then E99, and then 24 and 8 were remembered, and then you can hit paste, and then now it looks exactly like what we typed in the 83, and you get the same answer. So that is 2 different ways of doing it.